Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about primitive data structure. So let's get started. So before I talk about primitive data structures, let's put some light on what we have learned so far. So we begin our journey of data structures and algorithm with the introduction to data structure. And in introduction to data structure, we have studied what is meant by data structure, why we use it, advantages and applications of data structures. After introduction to data structures, we moved to analysis of algorithms and common loops. In this section, we have learned how to analyze algorithms and common loops and how to determine order of growth of algorithms and common loops. And we have also learned how to find time complexity and space complexity of an algorithm. After analysis of algorithms, we move to magic of mathematics. In this section, we have done few questions and we saw that how mathematics can help us in solving those problems very quickly. After magic of mathematics, we move to magic of bits. And in this section, we have learned bitwise operators like left shift, right shift, and or XOR, etc. And we have learned that how we can use bitwise operator to solve coding problems. So far in this course, we have covered all these topics. If you have not watched previous videos of all these topics, then I highly recommend to watch that video and then continue watching this video. You can find links to all the videos by clicking on the I button. Okay, moving on. So as you can see on the screen that data structures are classified into two categories. One is primitive and other is non-primitives. So in this video, we are going to focus on primitive data structures, and hopefully from upcoming videos, we will take each topic from non-primitive data structure and we are going to study each topic in detail. Okay, let's move on. So if we break the word primitive data structure, we get three words. One is primitive, one is data structure, and one is data. So what does it mean by data? Data is nothing but a collection of values that convey information. For example, let's say my name is Aziz and my age is 18. So here Aziz and 18 is a data, and this data represents or conveys some information that my name is Aziz and my age is 18. Okay, so this is what data is. Now what is data structure? So data structure is a way to organize data in such a way that it can be stored, updated and accessed efficiently, right? But why we need data structure? Because in computers, we want to store our data so that we can update or access it efficiently, right? So that is why data structure is a thing that provide a way to store our data in an organized way so that we can store, update and access efficiently. Okay, so now we know that what is meant by data and what is meant by data structure. Okay, but what does it mean by primitive data structures? So primitive data structure is the most basic type of data structures that are built into programming languages, and it provides a simple way to store data in its raw form. Okay, so let me explain you in a better way. So till here we understand that Aziz and 18 are data, and there is something called data structure that is used to organize and store this data. But the problem is we do not know which type of data it is. We know that 18 is a number and Aziz is a string, but computer doesn't know that 18 is a number or Aziz is a string. Okay, so that is why primitive data structure provides a type information of a data structure so that we can store strings in string data structure and number into integer data structure. And if we have decimal number like 1.2, we can store that type of data in other primitive data structures. If we have data like true and false, we can store that type of data in other primitive data structure. So for different types of data, programming languages provide different types of data structures to store that data efficiently. And those type of data structures are called primitive data structures because it is the most basic type of data structures. And by using primitive data structure, we can store any information in a raw form. Okay, you are going to understand this concept a little bit better when we move on to next topic. Okay, and the next point is primitive data structure stores single value in a specific location. So for example, you have a RAM, okay, and you have a memory locations. And if you want to store 18 in the RAM, it is going to store 18 here at a specific location. It's never going to happen that it stores 1 here and 8 here. So this is the main properties of primitive data structures, that it stores only single value, and single value is 18, and it stores it in specific location. Okay, so far so clear. So let's understand this primitive data structure with some examples. So let's say we have age, and age is 18, and I want to store this age in the memory. So to store 18 in the memory, programming languages provide primitive data structure called integers. Using these integers, we can store all the whole numbers in the memory. Similarly, if I want to store any value whose possible values are true and false, so in those cases, programming languages provide Boolean data structure that can help us to store such type of information like true and false. So when we use this type of data structures, then these data structures has some responsibilities. For example, if I store 18 in integers, then this is the responsibility of integers to allocate memory for 18 in the RAM. Okay? And it is the responsibility of integers to store that data efficiently so that we can access and update that data effectively and efficiently. Okay, so far so clear. So now you have a clear understanding of what is meant by data, what is data structure, and what is meant by primitive data structure. So far so clear. So you know about primitive data structure, but what is meant by non-primitive data structures? So these are the complex data structures that are built on top of primitive data structures, and it can store multiple values either in contiguous or random location. For example, strings are non-primitive data structures, arrays, stacks and queues, all of these are non-primitive data structures. So if I'm talking about this, how it's going to store, let's say you have a RAM and you have created an array. So how it's going to store? It's going to store some values here, some values here, some values here, or maybe here. Okay. So the location is not defined. It can store either in contiguous location or in random location. So here complex data structure means strings, arrays, stacks and queues. All these are complex data structures, and all these data structures are built on top of primitive data structure. So it means primitive data structure is the most important data structures you should have known, because it is the fundamental building block of complex data structures. Great. Now let's talk about some of the key features of primitive data structures. So the first key features is the size. So the size of all the primitive data structure is always fixed. It cannot grow or shrink. For example, integer is the most used data structure in all the programming languages to store whole numbers, and it takes up to 4 bytes or 32 bits. Even if you provide number that cannot be stored in 32 bits, in that case also it's never going to grow. It always remain in 32 bits only. Okay. So next feature of primitive data type is speed. As we know that it is a simple, it always is going to be fixed size, it is stored in a specific location. That's why it is really very easy for computer to process this type of data structures. The next key features is memory efficient. Because primitive data structures are always in fixed size, it takes minimal amount of memory as compared to non-primitive data structure. And we need primitive data structures for large amount of data. So because when we store large amount of data, we need memory efficient data structures so that we can store more data efficiently in a less amount of memory. Okay. The second feature of primitive data structure is portability. So primitive data structures are typically same across different programming languages and platform, which makes our code more portable. For example, in programming languages like Java, JavaScript, PHP or Python, you are going to get primitive data structure almost everywhere. So that if we write code in one programming language or one platform, so we can easily adopt this code to work on another platform or programming languages. So this is how portability of primitive data structure help us to adapt any programming language's code to work on another programming language also. So now let's talk about the types of primitive data structures available to us. So in this course, we are using Java as an implementation language, and Java provides 8 different types of primitive data structures. So the first data structure we are going to talk about is the byte data structure. So byte is a 8-bit signed complement integers. It means this data structure uses 8 bits to represent any integers, and it's going to be signed and complement. Let me explain you what is meant by signed and complement. So we have total bits, and how many bits we have? 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. So out of 8 bits, 1 bit from the left is always going to use as a sign bit to represent number as negative or positive. If this bit is set as 1, it means the number is negative, and if this bit is set as 0, it means number is positive. So that is why it is written as signed complement integers. So after fixing 1 bit for representing sign, we are left with only 7 bits. So if I ask you how many numbers are possible with 7 bits, then it's simple. 2 to the power 7, that is equal to 128. So we can have numbers from 0 to 127. So from all the bits to 0 to 111, we have total 128 numbers from 0 to 127. Okay. So this way we can store all the positive numbers. But byte also store negative numbers. So what about negative numbers? So when we are going to store negative numbers, we encounter one problem, and that problem is 2 zeros problem. So let me show you what is that. So after fixing most significant bits to represent sign of a number, let's say I have fixed one bit as 1, and on the other number I have fixed this bit as 0. And if I set all the remaining bits to 0, then we get 2 zeros. So this number represents negative 0 and this number represents positive 0. Okay. So now this is a problem. Just imagine that you have to deal with 2 zeros now. So everywhere in the program, or everywhere where you are doing any calculation in the program, you have to deal with 2 zeros. So in order to solve this problem, engineers came up with a different solution. And the solution says that if you want to store negative numbers, it's better to use 2's complement form, right? So let's understand what is meant by 2's complement. So let's say I want to store -1. So we have to first calculate the 2's complement of number 1. So the binary representation of number 1 is 00000001. We are going to invert all the bits, and we are simply going to add 1 to it. So after adding 1 to it, we get 2's complement of number 1. So when we store -1 in memory, it's going to store as 11111111, and this is the 2's complement form. And there is also one direct formula to find 2's complement. Let's say if I want to store -1, then it is represented as 2 to the power x minus 1. Here x is equal to number of bits. In our case, x is 7. So 2 to the power 7 minus 1 is going to be 128 minus 1, that is 127. So 2 to the power 6 plus 2 to the power 5 plus 2 to the power 4 and so on represents 127. So if I set all the bits to 1 and keep last bit as sign bit, we get 127. So this binary representation represents number 127, not 0. So now you understand that what is mean by sign numbers, and you also know what is mean by complement. So it means one bit is always reserved to represent sign, and negative numbers are stored in 2's complement form. That is why it is written as it is a 8-bit signed complement integers. Okay, but how does it solve problem of 0? So let's see this. So if you want to store positive 0, then we can simply convert it into binary representation and we store it in memory. So, and what about negative 0? So let's say this is negative 0 and we store negative numbers in 2's complement. So if you calculate 2's complement of 1, you simply invert all the bit and add 1 to it. So when you add 1 to it, 1 plus 1 is equal to 0, 1 carry, 1 1 is equal to 0, 1 carry, 1 1 is equal to 0, 1 carry, 0 1 carry, 0 1 carry, 0 1 carry, and you get 1 at the last. So in 2's complement, we simply have to discard this one. So if you look at this binary representation, it is exactly same as positive 0. So when we store -0 in 2's complement, we again get the positive 0 only. So this is how this 2's complement technique solves the problem of 2 zeros. Okay, great. I hope you got it. Now talking about the range of bytes, it means how many numbers we are actually going to store in bytes, including positive and negative numbers. So let's first understand with 4-bit integers. Let's say we have 4-bit integers, and here 1 bit is always reserved for representing sign number or sign bit. Okay, so how many positive numbers are possible? 2 to the power 3 minus 1. It means total 7 numbers are possible. So if we unset all the bits till we set all the bits and we are keeping the sign bit as positive, how many numbers are possible? This is equal to 0, and other than 0, 7 numbers are possible. So 1 to 7, 7. Total 7 positive numbers are possible to store in 4 bits of integers. And what about negative? We can store 2 to the power 3 numbers. It means 8 numbers we can store in negative. So it means 8 negative numbers we can store in this range. How? First, let's fix the most significant bit to 1 to represent negative numbers, and then from 111 to 000 we can store from -1 to -8. So the range comes out to be -1 to -8, 8 numbers. As we do not have any zeros in negative numbers, that's why we are able to store one number greater than positive number. Here we can store only 7 numbers, but here we can easily store 8 numbers. Now in bytes there are 8 bits. So how many numbers we can store? -2 to the power 7 to 2 to the power 7 minus 1, and it's going to be -128 to 127. It means we can store 128 negative numbers, 1 is 0, and 127 positive numbers. So now you understand what is byte data structure and what is the range it covers. It means how many numbers we can store in this primitive data structure. Moving on to next data structure, that is short. Short is 16 bits signed to complement integers. So the only difference is in byte there are 8 bits, and in short it uses 16 bit to represent number. So the range of short comes out to be -2 to the power 16 to 2 to the power 16 minus 1. Okay? Clear. The next data structure is integers. An integer uses 32 bits to represent integers, and it is also signed to complement integers. And the range of integers comes out to be -2 to the power 31 to 2 to the power 31 minus 1. Okay. Next coming up is long, and it is 64 bits unsigned to complement integers. But here you can store signed integers also. It means negative and positive, and the range is going to be -2 to the power 63 to 2 to the power 63 minus 1. But in Java 8 or later, you can also use unsigned integers. It means only positive integers, and here you get a large range. You can store numbers from 0 to 2 to the power 64 minus 1. And this is the advantage of using long, because using long you can store very large number also. Next coming up is the float data structure, and it is a 32-bit floating point. It means if you have a number like 1.5 or 2.3, you can store those type of numbers in float data structures. And the range of float is 1.4 e minus 45 to 3.4028 to 35 e 38. Here e simply means 10 to the power minus 45, and here e means 10 to the power 38. Okay. Next coming up is double. It is a 64-bit floating point. Only the difference is the range. Here it is using 32 bits, and here it is using 64 bit. And the range of double data structure is 4.9 e minus 324 to 1.777 blah 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 e 308. And here e represent 10 to the power minus 324 to 10 to the power 308. Okay. The next data structure coming up is Boolean. This data structure represents only one bit of information, and there are two possible values in this data structure, that is, one is true or false. So either we can use true to this data structure, or we can store false. It only supports two possible values. Okay. The next and the last data structure coming up is character data structure, and it is a 16-bit Unicode character. It uses 16-bit to represent any character, and the range of this data structure is 0 to 65,535. And we can store number A to Z, small letters, and we can also store capital A to capital Z, and many other special character also we can store in this data structure. So this is all about primitive data structures, and from upcoming videos we are going to study non-primitive data structure. So I hope now you have solid knowledge about what are primitive data structures and what are the key features of primitive data structures, what are the primitive data structures available in Java, what are the ranges of all the primitive data structures. So this is it for this video. Thanks for watching. See you in the next video.